12.2 Properties of Reflection. Reflection is a flip. We need to make sure that we know that when we're talking about reflection, we're talking about flipping it. Okay, and it is a transformation that flips a figure across a line. The line of reflection that the figure is flipped across to create a mirror image. Typically, we're flipping it across either the X or Y axis in 8th grade. So when you flip it across the X axis, the X value always stays the same. And when you flip it across the Y axis, the Y stays the same. Alright, so let's look at example 1. The figure of the triangle XYZ, graph the image of the triangle after reflection across the x-axis. Okay, what we can do is we can take a look at it graphically, and then we can also take a look at it algebraically, meaning if we never had the graph. Alright, so we have the plots X, Y, and Z. And we're going to reflect X prime, Y prime, and Z prime. The X is going to stay the same, but we are going to flip or take the opposite of Y. Alright, so we have the ordered pair 1, -3 for X. Now, if we take X and we leave it the same, it's still 1, but the opposite of -3 is +3. So, graphically looking at, this is 1, 2, 3 away from the x-axis, and this is 1, 2, 3. So we plot our point here, and we call it X prime. Okay, we look at Y. Y is the ordered pair 4, -1. Okay, because it goes over 1, 2, 3, 4, down 1. So we keep the X the same, so 4 is going to stay the same. The opposite of -1 is 1. So we go over 4, up 1, and we call this Y prime. Okay, the ordered pair for Z is 6, -5. The X stays the same. The opposite of -5 is 5. So we go to the right 6, up 5. And we call it Z prime. We connect our dots. And we have the reflection over the x-axis. Okay, let's take a look at another one. So the figure shows the pentagon A, B, C, D, E. Graph the image of the pentagon after reflection across the y-axis. Okay, so this time we're reflecting it across the y. So that means the y value is going to stay the same. That means we're going to take the opposite of x, and it's going to look like this. So we have A, B, C, D, and E, and we also have A prime, B prime, C prime, D prime, and E prime. Okay, A has the value -5, 6. So I go to the left 5, up 6. We're going to take the opposite of -5, which is 5, and we're going to keep y the same. So we're going to go 5, 6. So let's count 1, 2, 3, 4, 5, and we're going to go up 6. 1, 2, 3, 4, 5, 6. We're going to call this A prime. Okay, the ordered pair for B is -3, 6. So we go over 1, 2, 3, up 6. The opposite of negative 3 is 3, and we keep the y the same, so we're doing 3, 6. We go over 1, 2, 3, up, 1, 2, 3, 4, 5, 6. We call this B prime. Okay, the ordered pair for C is negative 2, 4. So we go over to the left 2, up 4. The opposite of negative 2 is 2. We keep the y the same. So we go to the right 2, up 1, 2, 3, 4. We call it C prime. Okay, D is negative 3, 1. So we went over to the left 3, up 1. The opposite of negative 3 is 3. And we have 1. So 1, 2, 3, up 1. And then lastly, E, negative 5, 1. So we went to the left 5, up 1. The opposite of negative 5 is 5. We keep the y the same. So we're going to go over 1, 2, 3, 4, 5, up 1. Call it E prime. We're going to connect our dots. Okay, and we have the reflection over the y-axis. Flip it over to the back side. Okay. On the back side, this is the algebraic reflections. If you reflect it over the x-axis, the x stays the same. If you reflect it over the y-axis, the y stays the same. Which algebraic expression below shows a reflection over the x-axis? So we have x, y, x stays the same, and the opposite of y. So the ordered pair is negative 2, 3. Negative 2 stays the same. The opposite of 3 is negative 3. So negative 2, negative 3, which is D. Alright, then we have the same thing, but this time we're reflecting it over the y-axis. The y is going to stay the same. So we're going to have the opposite of x. And so that's going to be 5, negative 4. So negative 5, y stays the same, so it is negative 4. So negative 5, negative 4, which is F. Alright, next question. Reflect STUVW using the algebraic expression xy and negative xy. So basically we are flipping it over the y-axis. Okay, and it says, what are the coordinates for the vertices S and U after the reflection? Okay, so S and we got negative X, Y, and U. Okay, so S is 1, 2, 3, 4, 5, and it is up 1, 2, 3, 4, 5, 6. So negative 5, 6. Okay, the opposite is 5, and the y stays the same, so it's 5, 6. U is 1, 2, so 2, and it is 1, 2, 3, 4, 5, 6. Okay, sorry, negative 6. So now we are going to take the opposite, which is negative 2, negative 6. Okay, so we're going to go ahead and reflect these. 5, 6, and negative 2, negative 6a. Okay, so this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sorry, my pen wasn't working. Okay, so that's S prime. And this one is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. This is T prime. So that connects to that. W is 1, 2. So 1, 2. And then we have V, which is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. This is V prime. And U is 1, 2. So 1, 2. So it's going to look like this, 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 and this, which is the reflection. All right, last question. Does a reflection affect the orientation? Yes. So it is opposite of the original. Does a reflection affect location? Yes. It moves to opposite quadrant. And does the reflection affect the size? No. Size stays the same. All right.